You are sitting in a room that feels still. The walls do not move. The floor does not stretch beneath your feet. Your body feels contained, stable, held together by familiar forces you never question. Air rests against your skin. Gravity presses you gently downward. Time appears to move forward at a steady, predictable pace. Everything about your immediate experience suggests that space is a quiet stage where events simply happen. But this sense of stability is an illusion created by scale. Right now, the space inside your room is expanding. The space between atoms is governed by forces that barely keep matter from dissolving. And far beyond the reach of your senses, the universe itself is growing at a rate that no longer fits our expectations. You were taught that expansion is something that happened long ago, after the Big Bang, and that it has been slowing ever since, a universe gradually coasting toward equilibrium. That story is wrong. Measurements made with increasing precision tell a different one. Expansion is not slowing down. It is accelerating. And the farther away you look, the faster space itself is pulling reality apart. This is not speculation. It is not philosophy. It is not metaphor. It is the result of direct observation. The problem is not that the universe is expanding. The problem is how fast it is doing so. And the deeper you follow this fact, the more unstable your assumptions about space, time, and existence become. The question is no longer whether the universe is growing. The question is what that growth is doing to reality itself. The illusion of still space. You instinctively treat space as empty and inert, a passive backdrop that holds objects in place while matter moves through it. This assumption feels reasonable because at human scales, space appears rigid. Distances remain constant. Objects stay where you left them. Nothing seems to stretch or tear. But space is not a container. It is a physical entity with properties, behavior, and dynamics. When cosmologists say the universe is expanding, they do not mean galaxies are flying outward through emptiness. They mean the fabric that defines distance itself is changing. The stability you experience is not proof that space is still. It is evidence that you are too small to notice its motion. What you perceive as stillness is the result of forces overwhelming expansion at small scales. Gravity binds planets to stars. Electromagnetism locks atoms into solids. These forces are strong enough to resist the stretching of space locally, masking its behavior entirely. Expansion does not stop inside your room. It is simply dominated. If those binding forces were removed, nothing would hold distance fixed. Without gravity or electromagnetic attraction, even the concept of shape would dissolve. Space would not tear objects apart violently. It would quietly redefine how far apart their parts are allowed to be. This is difficult to accept because you experience space as a stage, not an actor. You move through it. You measure it. You trust it. But in modern cosmology, space is closer to a process than a place. It evolves. It responds. It carries energy and curvature. The unsettling implication is not that space moves, but that motion itself depends on space's behavior. Distance is not a given. It is an outcome, something negotiated continuously by the underlying geometry of the universe. What feels solid and permanent to you is the result of a temporary balance, not a rule, but a condition. And conditions can change. Once you accept that space itself is active, the idea of an expanding universe stops being abstract. It becomes immediate. The ground beneath everything you assume to be fixed is not fixed at all. It is quietly, relentlessly changing. Expansion is not motion. It feels intuitive to imagine expansion as an explosion, matter rushing outward from a central point. But there is no center to the universe, and there is no edge it is expanding into. Every region of space expands relative to every other region. From your perspective, distant galaxies appear to recede. From theirs, you are the one moving away. This is not because either of you is traveling through space, but because the distance between you is being created continuously. Space is not carrying objects apart. It is redefining how far apart they are allowed to be. This distinction matters because motion implies a path and a reference frame. Expansion has neither. When a galaxy recedes due to cosmic expansion, it is not moving away from you in the way a car moves down a road. There is no road. There is no background against which that motion can be measured. The only thing changing is the scale that defines distance itself. You can imagine marking 2 points on a rubber sheet and stretching the sheet evenly. The points do not slide across the surface. The surface between them grows. Their separation increases without either point traveling anywhere. On cosmic scales, space behaves in the same way, except there is no external sheet and no higher dimensional space it stretches into. The geometry changes from within. This is why expansion does not violate the speed of light. Objects are not outrunning light through space. The space between them is expanding faster than light could cross it. Causality is preserved locally while breaking down globally. The unsettling implication is that distance is not a passive measure. It is dynamic. It evolves independently of objects. You can remain perfectly still relative to your surroundings, while the universe around you becomes unreachable. Once you understand that expansion is not motion, the universe stops behaving like a place you inhabit and starts behaving like a system that is actively rewriting its own scale. And that system does not require your movement to leave you behind. The discovery that changed the story. For much of the 20th century, scientists believed gravity would gradually slow cosmic expansion. Matter attracts matter. Over enough time, that attraction should weaken the outward motion left over from the universe's beginning. Then precise measurements revealed something deeply unexpected. Distant supernovae were dimmer than predicted. They were farther away than they should have been. The universe was not merely expanding, it was accelerating. This meant some unknown influence was overpowering gravity on the largest scales, an effect not tied to matter, radiation, or any known force. A pressure embedded in space itself, pushing everything apart faster as time passes. You have to pause here, because acceleration is not a small correction to the story. It is a reversal of its logic. Expansion slowing down would have meant the universe was gradually settling, spending the energy of its beginning. Acceleration means the opposite. It means something is actively driving the growth of space, and doing so more strongly as time goes on. The discovery did not come from a single observation. It emerged from independent teams using different instruments measuring the same phenomenon. Type Ia supernovae, events with remarkably consistent brightness, acted as cosmic distance markers. They were supposed to tell a simple story about how fast the universe was coasting. Instead, they revealed that the farther back you look, the more wrong your expectations become. Gravity should dominate on large scales. That assumption had guided cosmology for decades, but the data showed that gravity was losing, not gradually, completely. Beyond a certain scale, it was being overwhelmed by something that did not clump, did not dilute, and did not behave like any known form of energy. You are left with a universe whose dominant influence cannot be seen directly, cannot be turned off, and cannot be explained by existing theory. An expansion that feeds on itself. The unsettling realization is not just that the universe is accelerating. It is that the force shaping its future appeared silently, without warning, and rewrote the rules without asking whether your understanding was ready. Dark energy is not empty space. The name dark energy suggests a substance, something hidden, elusive, waiting to be detected. But the problem is more unsettling than a missing particle. Dark energy behaves as a property of space, not something inside it. As space expands, dark energy does not thin out. It becomes more dominant. The more space exists, the more strongly it drives further expansion. This creates a feedback loop where growth accelerates simply because growth has already occurred. Space is not empty. It is active, and it appears to want more of itself. You are used to energy behaving in familiar ways. Heat spreads out. Light fades with distance. Matter thins as volume increases. Almost everything you know about physics teaches you that expansion weakens influence. Dark energy violates that intuition completely. If dark energy were a substance, expansion would dilute it. But observations show no such dilution. Instead, its density remains nearly constant as space grows. This means that as the universe expands, the total amount of dark energy increases, not by flowing in from somewhere else, but by existing wherever space exists. This is why dark energy cannot be treated like a particle or a field sitting inside space. It is bound to the geometry itself. It behaves less like fuel and more like a rule, a background condition that space obeys automatically, without reference to matter or radiation. The unsettling implication is that space may carry an intrinsic tendency to expand, not because it is pushed, but because that is its default state. Expansion does not require a trigger once dark energy dominates. It is self-sustaining. You are not observing an explosion slowly running out of energy. You are observing a process that becomes more powerful as it unfolds, a universe where emptiness has weight, pressure, and consequence. When you picture the future of the cosmos, you are not looking at matter drifting apart into nothing. You are looking at space itself, taking over the dynamics of reality. And the more it succeeds, the less influence everything else has. Why faster expansion is a problem. Acceleration alone is not frightening. The unsettling part is what acceleration implies about the future structure of reality. If expansion continues to speed up, distant regions of the universe will eventually recede faster than light can travel between them. This does not violate relativity, because nothing is moving through space faster than light. Instead, space itself is expanding so quickly that information can no longer cross the growing gap. Entire galaxies will slip beyond causal contact, not hidden by distance, but erased from interaction entirely. You rely on the assumption that given enough time, any signal can eventually arrive. That distance is a challenge, not a barrier. Expansion undermines this assumption at a fundamental level. There are regions of the universe that are already unreachable, no matter how long you wait or how powerful your instruments become. This is not about visibility. Light from some galaxies will reach you for a while longer. Even as those galaxies move beyond reach, you will see them frozen in time, their last photons stretched thinner and thinner until they fade completely. Their future will continue without ever intersecting yours again. Causality, the idea that events can influence other events, becomes local rather than universal. Beyond a certain scale, cause and effect no longer connect. The universe does not just grow larger, it breaks into domains that cannot communicate, coordinate, or even acknowledge each other's existence. What makes this unsettling is its permanence. Once a region crosses this boundary, no physical process can restore contact. No force, no energy, no ingenuity can reverse the separation. The limit is built into the structure of expanding space itself. You are not witnessing a temporary phase of isolation. You are watching reality reorganize into fragments. Expansion does not destroy matter or energy. It destroys connection. And connection is what gives distance meaning, time coherence, and history continuity. As expansion accelerates, those concepts stop applying globally. The universe remains, but not as a single, shared reality. The event horizon. You cannot cross. There already exists a boundary around you, a cosmic horizon beyond which light emitted today will never reach your location, no matter how long the universe exists. This horizon is not a wall. It is a limit defined by expansion rate. Objects beyond it are not merely far away. They are permanently inaccessible. Their future and your future no longer share a timeline. The universe is not only large, it is actively isolating itself. You are accustomed to horizons that move when you move. A hill blocks your view until you climb it. Distance hides objects until you travel closer. This horizon does neither. It is not tied to your position or your motion. It is woven into the geometry of the universe. Every moment that passes redraws this boundary, not because you are moving, but because space is expanding. Regions that are currently visible will eventually cross it, not suddenly, not dramatically, but inevitably. The light they emit after that moment will never reach you. This creates a strange asymmetry. You can see the past of objects whose future you will never observe. Their history intersects yours briefly, then diverges forever. They do not disappear because they stop existing, but because the structure of space stops allowing information to travel between you. The concept of a shared universe begins to fail here. What you call reality is defined by what can affect you. Beyond the horizon, events continue, but they are causally disconnected. They might as well belong to a different universe. This is not a speculative outcome. The horizon already exists. It is a direct consequence of accelerated expansion. You are living inside a shrinking causal bubble, even as the universe grows larger. The unsettling implication is not that you are small in a vast cosmos. It is that the cosmos itself is gradually withdrawing. And no matter where you go or how long you wait, this boundary cannot be crossed, only watched as it closes in. A universe that forgets itself. As expansion accelerates, the observable universe shrinks in practice. More and more galaxies cross the horizon and disappear from view. Over immense spans of time, only gravitationally bound structures remain visible. From any future vantage point, the universe will appear emptier, simpler, and smaller. Evidence of its vast past will fade not through decay, but through disconnection. Knowledge itself becomes cosmologically fragile. You tend to think of loss as destruction, stars exploding, matter breaking apart, records eroding over time. But this kind of loss is quieter. Nothing is damaged. Nothing collapses. Information simply loses its ability to reach you. Each galaxy that crosses the horizon takes its history with it. The light that once told you about its stars, its structure, its motion, is replaced by silence. Not because the signal weakens, but because space no longer permits the signal to arrive. From within such a universe, the past becomes harder to reconstruct. The cosmic microwave background fades beyond detectability. distant galaxies vanish. The clues that once revealed expansion, origins, and structure are erased by geometry, not entropy. Observers in that future will not see an expanding universe. They will see a quiet island of stars surrounded by darkness. With no evidence of large-scale motion, they may conclude that the universe is static, limited, and unchanging. The universe will not remember its own beginning, not because the information is destroyed, but because it is no longer shared. Reality fragments not only physically, but epistemologically. What you understand about the cosmos depends on connection. When connection fails, so does explanation. Truth becomes local. History becomes incomplete. The unsettling implication is that knowledge has a horizon, just like light. There is a time beyond which certain facts can no longer be known, not because they are false, but because the universe has grown too large to remember them. Time depends on expansion. You experience time as a steady flow, independent of space. But in cosmology, time and expansion are deeply linked. The rate at which the universe grows determines how events are ordered, how structures form, and whether complexity is even possible. If expansion had been slightly faster in the early universe, galaxies would never have formed. Slightly slower, and everything would have collapsed back into itself. Your existence depends on a narrow balance that no longer holds. Time, as you experience it, feels universal. Seconds pass the same way everywhere. Causes precede effects. But on cosmic scales, time is inseparable from the behavior of space. Expansion sets the tempo at which the universe unfolds. In the early universe, expansion acted as a regulator. It determined how quickly matter could clump, how long radiation dominated, and when structures could emerge. Too rapid, and matter would be torn apart before gravity could act. Too slow, and gravity would have ended the universe before complexity had a chance to arise. This balance allowed time to have structure. Eras followed one another. First particles, then atoms, then stars, then galaxies. Time was not just passing, it was shaped. As expansion accelerates, that shaping influence changes. Processes that once unfolded gradually become impossible across large distances. Synchronization breaks down. Events that would have shared a common future no longer do. The unsettling implication is that time itself becomes local. Not everyone shares the same cosmic clock. Different regions of the universe drift into timelines that no longer intersect. Cause and effect remain intact nearby, but lose coherence globally. Your sense of time assumes a universe that holds together. Expansion is quietly undoing that assumption. The future is not a single direction the universe moves toward. It is a collection of diverging timelines, shaped by how space continues to grow. Time does not simply pass. It depends on whether the universe remains connected enough for passage to matter at all. The coincidence that has no explanation. Right now, dark energy and matter contribute comparable amounts to the universe's total energy density. This is strange because they evolve differently over time. Matter becomes diluted as space expands. Dark energy does not. Their near equality today appears accidental. A fleeting alignment in cosmic history with no known reason. You exist at the precise moment when the universe transitions from matter-dominated to expansion-dominated. There is no accepted explanation for why this moment should coincide with observers like you. For most of the universe's history, matter clearly dominated. Galaxies formed, stars ignited, structures grew. Dark energy was present, but irrelevant. Its influence was drowned out by the density of matter packed into a smaller volume of space. In the far future, the opposite will be true. matter will be diluted beyond significance. Dark energy will dominate completely, driving expansion while structures drift into isolation. There will be no balance, no competition. You live in the brief interval between these two regimes, a narrow window where both influences matter at once, where gravity still shapes structures, but expansion is beginning to pull them apart. This coincidence is not required by any known law. It is not predicted by theory. It simply appears in the data. The timing could have been vastly different, and the universe would still exist, but you would not. Some interpret this as selection. You observe this moment because only during this moment can observers arise. That explanation does not resolve the coincidence. It reframes it. The unsettling implication is that your existence is tied to a temporary balance that has no deeper justification. You are not living at a typical time in the universe's history. You are living at a turning point. The universe is changing phases, and you are present precisely as one era gives way to another, without knowing why this moment allows you to notice it at all. Expansion changes. The meaning of distance. Distance feels absolute. A meter is a meter. A light year is a light year. But in an expanding universe, distance is not fixed. It depends on when you measure it. Light from distant galaxies left billions of years ago, when space was smaller. By the time it reaches you, the distance it traveled has changed. The past and present are connected by geometry that refuses to stay still. You are used to thinking of distance as something that exists independently of time. 2 points are separated by a fixed amount of space, and that separation remains the same unless something moves. Expansion breaks this intuition. Separation can change even when nothing moves at all. When you observe a distant galaxy, you are not seeing it where it is. You are seeing it where it was, at a time when the universe was denser and smaller. The light reaching you has crossed a space that kept expanding while the journey was underway. The path itself was stretched after the light had already passed through it. This creates multiple definitions of distance. How far away an object was when the light was emitted. How far away it was while the light was traveling. How far away it is now. All of them are correct, and none of them fully capture what distance means. The unsettling implication is that distance is not a simple property of space. It is a relationship between space and time. To ask how far away something is without asking when is to ask an incomplete question. As expansion accelerates, these distinctions grow more severe. Objects can be receding faster than light in terms of distance growth, while their light still reaches you. Eventually, even that connection fails. You do not inhabit a static map. You inhabit a dynamic geometry where separation evolves continuously. What you call far is not just a measure of length, it is a measure of history. Nothing holds the large-scale universe together. On small scales, forces bind structures. Atoms are held by electromagnetism, planets by gravity, galaxies by their own mass. But beyond a certain scale, nothing counters expansion. There is no mechanism that enforces coherence across the universe as a whole. No restoring force, no equilibrium state. Growth continues because nothing tells it to stop. You instinctively expect large systems to be more stable than small ones, more mass, more gravity, more resistance to change. But the universe violates that expectation. The larger the scale, the weaker the binding becomes. Gravity dominates locally, but it has a finite reach. It can hold galaxies together and even clusters of galaxies, but only up to a point. Beyond that scale, the average density becomes too low. Expansion takes over, not because it is strong, but because gravity becomes irrelevant. There is no global force acting to preserve the universe as a single structure. No tension holding space in place. No boundary condition that limits its growth. The equations that describe cosmic expansion do not contain a term that says enough. This means the universe does not behave like an object. It behaves like a process without a preferred endpoint. Growth is not something it is doing temporarily. It is what it is. The unsettling implication is that coherence is local and temporary. The connected universe you observe is not guaranteed to remain connected. It exists because conditions currently allow it to exist. As expansion accelerates, even the largest bound structures become islands in an ever-growing sea of space. There is nothing waiting to pull them back together, nothing that ensures a shared future. The universe is not held together by design or necessity. It is held together only where forces still manage to compete with expansion. Everywhere else, separation is the default outcome. Acceleration has no known cause. Dark energy fits observations mathematically, but it does not explain itself. It has no underlying theory that connects it cleanly to known physics. Attempts to calculate its value from quantum theory overshoot observations by orders of magnitude that defy intuition. The most dominant component of the universe is also the least understood. Reality is being shaped by something we can describe but not explain. You are used to physics offering reasons. Forces have carriers, effects have sources. Even when mechanisms are complex, they eventually reduce to something concrete. Dark energy does not follow this pattern. It enters the equations as a term that works, not one that makes sense. When physicists try to derive its value from known principles, the result is catastrophically wrong. Not slightly off, not uncertain. Wrong by factors so large they undermine confidence in the calculation itself. There is no adjustment that fixes the gap. The mismatch is fundamental. This leaves you in an unfamiliar position. The expansion of the universe is accelerating for a reason that has no physical story attached to it. No particles to detect, no interaction to isolate. Only a number that must be inserted by hand to make the universe you observe mathematically possible. The unsettling implication is that explanation has limits. You can predict how fast the universe expands tomorrow without knowing why it expands at all. Description works. Understanding does not. This is not a temporary gap in knowledge with a clear path forward. Dark energy has resisted decades of theoretical effort. Each proposed explanation introduces new problems or requires assumptions more troubling than the phenomenon itself. You are living inside a universe whose future is dominated by something fundamentally opaque, not hidden by distance or technology, but by principle. Expansion is accelerating, not because we understand the cause, but because reality continues to behave as if the cause exists, whether you can explain it or not. Expansion alters. What exists? When regions of space lose causal contact, they effectively stop sharing reality. Events in one region can no longer influence the other. Over time, the universe fragments into isolated islands of existence. This is not destruction. It is separation so complete that interaction becomes impossible. Existence itself becomes local. You tend to think of existence as absolute. Either something exists or it does not. But in a universe governed by causal limits, existence is relational. To exist for you is to be able to affect you, directly or indirectly. When expansion severs that possibility, existence loses its universality. Regions beyond your causal horizon continue to evolve, but their events no longer participate in your reality. They cannot shape your future. They cannot inform your present. They cannot be known in any operational sense. This is not a matter of ignorance. It is a structural limit. No amount of time or technology can restore contact once the boundary is crossed. Space itself enforces the separation. As expansion accelerates, more of the universe becomes causally irrelevant to you. Not in principle, but in fact. What remains connected defines the entirety of your accessible reality. The unsettling implication is that the universe does not remain a single coherent system. It becomes a collection of independent domains, each internally consistent but mutually unreachable. Reality fractures without breaking. This challenges the idea of a shared cosmic history. Past events that once influenced vast regions become confined to shrinking pockets of relevance. History becomes regional. Cause and effect lose their global scope. You are not watching the universe end, you are watching it divide. Expansion does not erase matter or energy, it erases connection. And without connection, the meaning of existence itself quietly changes. The future of structures you take for granted. If acceleration continues indefinitely, even galaxy clusters will eventually become isolated. Over inconceivably long timescales, stars burn out, matter decays, and expansion dominates everything. The universe does not end in fire or collapse. It thins, it stretches, it fades into disconnected remnants drifting in an ever-growing void. You are used to thinking of the universe as a place filled with structure. Galaxies, clusters, filaments. A cosmic web that gives shape and coherence to everything you observe. This structure feels permanent because its timescales exceed human history. But permanence is an illusion created by patience. As expansion accelerates, the first things to be lost are not objects, but relationships. Galaxy clusters that are currently bound will slowly lose contact with one another, not because they break apart internally, but because the space between clusters grows faster than gravity can compensate. Within those clusters, stars continue their lives. They burn, they age, they die. Over trillions of years, star formation slows and then stops as gas is exhausted. Existing stars fade into remnants. White dwarfs cool. Neutron stars spin down. Black holes remain, but isolated. Even these remnants are not immune. On timescales far beyond anything you can intuitively grasp, matter itself may decay. Protons, if unstable, disappear. Black holes evaporate through slow radiation. What remains becomes increasingly diffuse. Throughout all of this, expansion never needs to destroy anything directly. It simply keeps creating more space between whatever remains. Distances grow, interactions cease, energy spreads thinner. The unsettling part is how quiet this future is. There is no final event, no moment where the universe changes state dramatically. The process is gradual, monotonic, and irreversible. Eventually, each isolated region becomes a nearly empty pocket of space containing a handful of particles and an enormous amount of expansion-driven emptiness. Time continues, but nothing meaningful happens. The universe does not die in a way you can point to. It becomes irrelevant to itself. Structure, complexity, and interaction fade not because they are forbidden, but because space has made them impractical. What you take for granted now, stars overhead, galaxies beyond them, a connected cosmos, exists only because you are early. Expansion ensures that this condition is temporary. Expansion is not slowing down. Every new measurement confirms the same trend. The universe is not approaching rest. It is moving away from cohesion. There's no sign of reversal, no hint of stabilization. Expansion is not a phase. It appears to be the defining behavior of the cosmos going forward. You might expect acceleration to be temporary, a surge that peaks and fades. In most physical systems, growth exhausts its cause. Energy dissipates, motion settles. Expansion does not follow that pattern. Each generation of observations, more precise than the last, reinforces the same conclusion. The rate is increasing, not leveling off. There are theories that once promised a reversal, models where expansion slows, halts, and turns inward, a universe that collapses back into itself. Those possibilities required specific conditions the universe does not appear to meet. Instead, the data points toward persistence. Dark energy behaves as if it will continue dominating indefinitely. There is no observed mechanism that weakens it over time, no competing influence growing strong enough to counteract it. This means the future of the universe is not open-ended in the way you might hope, not balanced between possibilities. It is biased, skewed toward continued separation. The unsettling implication is that expansion is not something happening to the universe. It is what the universe is doing by default. There is no natural state of rest waiting ahead, no equilibrium it tends toward. Even the idea of a final configuration becomes ambiguous. Expansion does not aim for completion. It does not converge. It simply continues. As distances grow without bound, fewer and fewer processes remain possible. Interactions that once shaped cosmic history become increasingly rare. Complexity becomes harder to sustain, not because it is unstable, but because the conditions that allow it stop recurring. You are living in a universe that is not winding down, but opening up endlessly, not growing richer, but thinner, not becoming more chaotic, but more empty. Expansion is not a story with an ending. It is a direction without a destination. And everything you recognize as structure, history, and connection exists only because that direction has not yet carried the universe too far to sustain them. Space may be creating energy. If dark energy is tied to the fabric of space, then as space grows, the total amount of dark energy increases. This suggests that energy itself may not be conserved in the way you expect on cosmic scales. One of the most fundamental assumptions of physics becomes ambiguous when applied to the universe as a whole. You are taught that energy is conserved. It can change form, move between systems, or spread out, but the total never changes. This principle works flawlessly in laboratories, in stars, in every experiment you can perform. It feels absolute. Cosmology quietly undermines that certainty. When space expands and carries dark energy with it, the universe gains more of this energy simply by having more space. There is no identifiable source. Nothing loses energy to compensate. The bookkeeping that works so well in local systems fails when the system is the universe itself. This is not a technical loophole. It is a consequence of how energy is defined. Conservation relies on time symmetry, on the idea that the laws of physics do not change from moment to moment. An expanding universe breaks that symmetry globally. Time is not uniform when the geometry it moves through is changing. As a result, energy conservation is not guaranteed on cosmic scales. It becomes a local rule, not a universal one. In your immediate environment, energy behaves exactly as expected, but globally, the concept loses its meaning. The unsettling implication is that space itself may act as a generator. not in a mechanical sense, but in a geometric one. By expanding, it increases the total energy associated with its structure. This does not violate known physics. It reveals its limits. The rules you rely on are context-dependent. They apply where space-time is approximately static. They do not automatically extend to a universe that is actively evolving. You are living inside a system where one of the deepest assumptions about reality holds only approximately. Energy is conserved where things are bound, stable, and small. On the largest scale, the universe does not promise such consistency. Expansion is not just changing distances. It is changing which principles remain meaningful. And the more space grows, the more the universe behaves in ways that resist your expectations about how reality should account for itself. The shape of reality is changing. Expansion does not just affect where things are. It affects what configurations are possible. Certain patterns, interactions, and histories become forbidden simply because space grows too quickly for them to occur. Reality has a geometry that evolves, and that evolution constrains existence. You tend to think of geometry as passive, a backdrop that shapes how things look, not how they behave. But in the universe you inhabit, geometry is active. It determines which trajectories are allowed, which interactions can complete, and which structures can ever form. In the early universe, geometry was compact. Distances were small enough that particles interacted constantly. Information traveled easily. This allowed complexity to emerge. As space expanded, geometry relaxed just enough to permit stable structures without tearing them apart. As expansion accelerates, geometry shifts again. Distances increase faster than signals can traverse them. Interactions that once required only time now require proximity that no longer exists. This means some processes are not just unlikely in the future, they are impossible. Not because the laws of physics forbid them, but because space does. You can imagine two particles separated by an ever-growing distance. Even if nothing pushes them apart, the geometry ensures they will never meet. Their potential interaction is erased before it can occur. The unsettling implication is that reality does not merely evolve in time, it loses possibilities. Histories that could have happened under different geometric conditions are permanently excluded. Expansion acts as a filter on existence. It decides which structures can persist and which cannot, independent of local physics. The universe is not just changing, it is narrowing the set of futures it allows. What you call reality is not a complete catalog of what could exist. It is the subset permitted by the current shape of space. As that shape evolves, so does the range of possible experiences, outcomes, and structures. You are not living in a universe where anything allowed by physics will eventually happen. You are living in one where geometry quietly closes doors, not by force, but by distance. The universe is becoming simpler. Early in cosmic history, matter clumped, structures formed, complexity increased. Expansion now reverses that trend on the largest scales. The future universe is not chaotic, it is sparse. Order gives way to emptiness, not through violence, but through distance. You are used to associating the passage of time with increasing complexity. From simple beginnings, systems differentiate. Particles form atoms. Atoms form molecules. Molecules form stars, planets, and eventually observers capable of asking questions about the universe they inhabit. This progression feels natural, almost inevitable, but it is not permanent. Complexity arose because conditions allowed it to arise. The early universe was dense enough for interactions to occur frequently, but not so dense that everything collapsed immediately. Expansion created just enough room for structures to stabilize without being torn apart. Complexity was a temporary compromise between attraction and separation. As expansion accelerates, that compromise breaks down. On small scales, complexity persists for a long time. Stars burn, chemistry continues, local systems remain rich and structured. But on the largest scales, the trend has already reversed. The cosmic web that once grew more intricate is thinning. Filaments stretch, voids widen, connections weaken. This is not entropy in the usual sense. The universe is not becoming more disordered through random motion. It is becoming simpler through isolation. Structures do not dissolve. They drift apart until their relationships no longer matter. In the distant future, each gravitationally bound region becomes an island. Inside each island, remnants of complexity persist for a while. But there is no larger structure linking them, no global pattern, no shared environment. You can think of it as a loss of context. A star in a galaxy is part of a larger system. A galaxy in a cluster participates in an even larger one. As expansion continues, those layers peel away. Systems remain, but their embedding frameworks vanish. Eventually, even the largest bound systems exhaust their internal sources of complexity. Stars stop forming. Energy gradients flatten. Processes slow. Not because the laws of physics fail, but because the conditions that allow rich behavior disappear. What remains is not chaos. Chaos requires interaction. It requires systems influencing one another unpredictably. The future universe offers fewer and fewer opportunities for that. It becomes quiet, not because it is stable, but because nothing can reach anything else. The unsettling implication is that complexity is not favored by the universe in the long term. It is tolerated briefly, allowed under specific conditions, then gradually suppressed. This challenges an intuitive narrative about progress. There is no guarantee that complexity increases indefinitely. There is no cosmic obligation to preserve structure, meaning, or richness. Those qualities emerge locally and temporarily, then fade as geometry takes over. The universe does not need to destroy complexity directly. It only needs to stop supporting it. Expansion accomplishes this by stretching space faster than interactions can compensate. From a certain perspective, the universe is simplifying its own description. Fewer interactions, fewer structures, fewer correlations. The equations that describe it become easier to solve because there is less happening. This is not a failure of the universe. It is a consequence of its evolution. A universe that expands without bound naturally moves toward states where fewer relationships exist. You are living during the era when complexity is still widespread enough to notice itself. When the universe still contains large-scale structure, gradients, and histories that intersect. This is not the default state of the cosmos. It is a transient one. As expansion continues, the universe does not become more mysterious. It becomes more trivial. Vast, empty regions dominate. Isolated systems persist briefly, then fade. The richness you experience now is not what the universe is becoming. It is what it is leaving behind. Order does not collapse into disorder. It stretches into irrelevance. Observation has a built-in expiration date. There will come a time when cosmology itself becomes impossible. When the expansion has erased all evidence of the universe's origins from view. Observers in that future will see a quiet, isolated region with no trace of expansion, no background radiation, no visible galaxies beyond their own. The truth of the universe will still exist, but it will be unreachable. You tend to assume that knowledge accumulates, that once something is discovered, it remains discoverable, that the universe, however vast, leaves permanent clues behind. Cosmology quietly contradicts this assumption. What you know about the universe depends on signals that are already fading. The cosmic microwave background, the afterglow of the early universe, grows weaker as space expands. Its wavelengths stretch, its temperature drops. Eventually, it becomes indistinguishable from background noise, not because it vanishes, but because it loses contrast against an ever-expanding space-time. The same is true of distant galaxies. Each one that crosses the cosmic horizon removes a data point, not a measurement you failed to take, but one that becomes impossible to take. The universe does not archive its past in a way that guarantees access. From the perspective of future observers, the universe will look static and small. Their sky will contain only the remnants of a single gravitationally bound structure. No evidence of large-scale expansion, no visible recession of distant galaxies, no hint that space itself is dynamic. With no observational access to the broader cosmos, their theories will converge on a quiet, eternal universe. And based on the evidence available to them, that conclusion will be reasonable. This is not a failure of intelligence or imagination. It is a failure of access. The unsettling implication is that truth can become inaccessible without being destroyed. Facts about the universe's origin, scale, and evolution remain true, but unprovable. The universe does not care whether it can be understood. It does not preserve evidence for future observers. You are living during a narrow observational window, a time when expansion has not yet erased its own footprints. When the universe is old enough to have a history and young enough to still reveal it, this window is closing. As expansion accelerates, information is lost not through entropy, but through geometry. The past is not erased. It is pushed beyond reach. The universe remembers, but cannot communicate what it remembers. This forces a reconsideration of what knowledge means. You do not discover eternal truths in a timeless arena. You extract information from a system whose structure determines what can be known, and for how long. Observation is not a neutral act. It is an opportunity granted by cosmic conditions. When those conditions change, observation fails, regardless of intent. The future universe will not be less real than the present one, but it will be less legible. The rules that once allowed observers to reconstruct cosmic history will no longer apply. The unsettling realization is not that observers will be wrong. It is that they will be right for their universe, and still fundamentally mistaken about the larger one they can no longer see. Knowledge has a horizon, and like all horizons in an accelerating universe, once it is crossed, it cannot be reached again. You exist during a brief window. Your ability to measure expansion, detect distant galaxies, and infer cosmic history depends on timing. You live during a narrow era when the universe is both old enough to have structure and young enough to still reveal its past. This is not a permanent condition. It is a temporary alignment. You are accustomed to thinking of your moment in history as ordinary. One point among many, a random slice of time with no special status. Cosmology quietly disagrees. If you had existed much earlier, the universe would have been opaque. Radiation dominated everything. Matter had not yet settled into stars or galaxies. There would have been no stable structures to observe, no long-lived systems to study, no clear record of cosmic evolution. The universe would have been real, but unreadable. If you existed much later, the universe would again be unreadable, but for the opposite reason. expansion would have erased most evidence of its past. Distant galaxies would have vanished beyond the horizon. The cosmic microwave background would have faded into irrelevance. Large-scale structure would no longer be visible. You exist between these two limits. This is the only era in which the universe simultaneously contains complex structures and exposes the clues that explain how those structures came to be. It is the only time when the sky still holds both memory and matter. This window is not wide. On cosmic timescales, it is fleeting. You are able to infer the Big Bang because light from the early universe can still reach you. You can measure expansion because distant galaxies are still visible and still receding in a measurable way. You can reconstruct cosmic history because the universe has not yet erased its own evidence. None of this is guaranteed to last. The unsettling implication is that your understanding of the universe is not just the result of intelligence or technology. It is the result of timing. You are not merely an observer. You are an observer who arrived before the universe closed its records. This challenges a deep assumption about knowledge. You tend to believe that the universe is fundamentally knowable and that progress is a matter of patience and refinement. But cosmology suggests that some truths are only accessible during specific epochs. Miss the window, and the same universe tells a different story. From a future perspective, the universe will appear simpler, smaller, and static. From an earlier perspective, it would have appeared chaotic and opaque. Only now does it present itself as something that can be understood at all. This does not mean the universe is designed to be observed. It means observation is conditional. You are living at a moment when the expansion rate, the age of the universe, and the distribution of matter align just enough to make cosmic understanding possible. That alignment is already breaking. As expansion accelerates, the conditions that allow inference degrade. The universe becomes less informative, not because it changes its laws, but because it changes what can be accessed. The unsettling realization is that meaning itself may be time-bound. The narratives you construct about the universe rely on access to information that will not always be available. The same cosmos will later appear mute, not because it has nothing to say, but because it no longer speaks to anyone who can hear it. You exist during a brief window when the universe can still explain itself, and that window is closing quietly, without announcement, driven by the same expansion you are only now beginning to understand. Expansion redefines what it means to be far away. In an accelerating universe, far does not mean distant, it means unreachable. Beyond a certain scale, separation is not a matter of effort or time, it is absolute. Space itself enforces isolation. You are used to thinking of distance as something that can always be overcome. Far implies effort, more fuel, more time, better technology. Even the most distant places feel, in principle, connected. They exist on the same map. Expansion quietly removes that assumption. In an accelerating universe, there is a fundamental difference between distant and unreachable. Distant objects are far but connected. Unreachable objects are not merely farther away. They are separated by a growing gulf that no signal can cross, no matter how long you wait. This is not a limitation of speed. It is a limitation of geometry. You could imagine a spacecraft traveling forever, accelerating endlessly, never slowing down. Even then, there are regions of the universe it could never reach. Not because it is too slow, but because the space between you and those regions grows faster than any journey can compensate for. This turns distance into a one-way concept. Regions that were once connected drift beyond reach permanently. There is no return path, no future convergence. The separation hardens into a boundary written into space-time itself. What makes this unsettling is how unintuitive it is. Nothing dramatic marks the transition from distant to unreachable. There is no visible wall, no sudden disappearance. The boundary is defined by rates, not locations. A slow, continuous process produces an absolute limit. From your perspective, galaxies beyond this limit do not feel different at first. You can still see their past light. You can still measure their redshift. But their future is already sealed away from you. Even as you observe them, they are no longer part of your causal universe. This creates a strange tension between what you can see and what you can influence. Visibility persists after connection is lost. You watch objects that can no longer respond to anything you do and whose future you will never witness. The unsettling implication is that the universe is actively redefining proximity. Near and far are no longer measured only in space, but in causal possibility. Two objects can be separated by vast distances and still be part of the same reality. Others can be closer and yet fundamentally disconnected. Expansion makes isolation a structural feature of the universe, not an accident of scale. Over time, more and more of what you now consider part of the universe becomes unreachable, not hidden, not destroyed, simply excluded from interaction. This has consequences beyond astronomy. It reshapes what it means to share a universe. A shared universe is one where events can, in principle, affect one another. As expansion accelerates, that shared domain shrinks. You do not inhabit the whole universe. You inhabit a region defined by what can still reach you. Everything beyond that region continues to exist, but not for you. This challenges a deeply held intuition. You tend to believe that the universe is a single unified place, and that separation is a matter of scale. Expansion reveals that unity itself is conditional. In the long term, the universe does not become more connected as it grows larger. It becomes more fragmented. The growth of space does not create openness, it creates barriers. Far away is no longer a question of where something is. It is a question of whether it still belongs to your reality. And as expansion continues, the answer to that question becomes no more often than yes. The question expansion forces you to face. If space can grow without limit, if reality fragments into isolated regions, and if the dominant force shaping existence has no known cause, then expansion is not just a physical process. It is a statement about the nature of the universe. Not a place tending toward balance, not a system seeking completion, but a reality that moves relentlessly toward separation, carrying you with it, whether you notice or not. You are accustomed to thinking of the universe as something that evolves toward states, equilibrium, heat death, collapse. Even uncertainty feels like a destination. Expansion resists that framing. It does not point toward a final configuration. It does not aim for resolution. It simply continues. This forces a question you cannot avoid once the evidence is taken seriously. What kind of universe behaves this way? A universe governed by expansion does not prioritize cohesion. It does not preserve connection for its own sake. It does not ensure that what exists together now will remain together later. Separation is not an accident or a failure. It is the default outcome. You may be tempted to interpret this in terms of purpose or intention, but the data offers none. Expansion does not act as if it wants anything. It acts as if wanting is irrelevant. The universe does not strive. It unfolds according to rules that do not care whether the results feel meaningful, stable, or comprehensible. This is deeply unsettling because it contradicts an implicit expectation. You expect reality to be organized in a way that favors persistence, that what comes together should, at least in principle, be able to remain together. Expansion denies that expectation on the largest scales. The universe is not arranged to keep itself whole. As expansion accelerates, shared reality becomes a temporary condition. What exists together now does so because geometry still allows it, not because the universe is structured to maintain unity. This reframes your position in the cosmos. You are not inside a system designed to sustain observers indefinitely. You are inside a transient configuration that briefly permits observation before withdrawing the conditions that made it possible. The question expansion forces you to face is not about the future of galaxies or stars. It is about whether connection itself is fundamental. If the universe naturally evolves toward isolation, then connectedness is not a permanent feature of reality. It is a phase, a condition that arises under specific circumstances and then fades as those circumstances change. This has implications that extend beyond physics. Meaning depends on relationship. History depends on shared timelines. Identity depends on continuity. Expansion quietly undermines all of these by limiting what can remain related over time. You may want to believe that reality is ultimately unified, even if temporarily divided. Expansion offers no such reassurance. It does not promise reunification. It does not hint at cycles or returns. It points toward an ever-increasing number of disconnected domains, each internally consistent and externally irrelevant. This is not a dramatic ending. There is no catastrophe, no final rupture, just a steady erosion of shared context. The unsettling part is not that the universe ends. It is that it does not. It continues, but in a way that increasingly excludes the possibility of a common story. You are carried along by this process without resistance, not because you are powerless, but because power itself is local. There is no action you can take that affects the global trend. Expansion does not respond to effort, intention, or understanding. It simply proceeds. The question, then, is not how to stop it or reverse it. The question is how to think about a universe that does not converge toward unity, purpose, or closure. A universe where separation is not a breakdown, but a consequence of its most basic behavior. You are not watching something go wrong. You are watching something be revealed. Expansion forces you to confront the possibility that reality is not oriented toward coherence, that connection is temporary, that shared existence is contingent, and that whatever meaning you extract from the universe exists within a narrow window where separation has not yet gone too far to erase it